Hey guys, we are diving into our very first section here, and that is 1.1. The book calls it equation solving and modeling, but really it's all about multiple representations of functions. I love abbreviating that as Mr. of, right? Just to make our lives a little bit easier. How do we translate? Between representations. There's different things we can look for. Different clues, right? There's key words we might want to look for. There's that determine things about a graph, or there's key parts in the equation that determine things in the graph, or there's key parts in the graph that tell us something about what the equation looks like, or we can use the table to create things. So there's four kind of representations that we're really diving into. The first is verbal. We're talking about verbal models. Verbal models, not real exciting. All we're really getting at is that a verbal model are the words describing a situation. You either have done or will do a bunch of problems about bathtubs. And the verbal model is what's telling the story of the person filling the tub. The phone rings, so they have to stop filling the tub. They filled it too full, so they need to drain some water out. That's what we mean when we say verbal model. And those words, even though they are telling a story or they're more real world, we have to think about what do they mean in terms of math. The next model is the algebraic model. And the algebraic model is the equation with variables and equal signs and things like that, right? The equation will tell us something, and it might tell us, right? In the case of the bathtub problems, any of the parts of the equation where the slope was positive in the equation, that meant we were filling the tub because the water was increasing, right? And if the slope was negative, then the water was decreasing. And if it was constant, there was no x, it was just a constant number, that meant the water level was at that level and not changing. So lots of things in the equation that can really clue us into what's going on and what we should expect to see in the graph. However, before we talk graphs, let's talk about numeric. Numeric model, that could be a table or just data values in general, right? The final version is our graphical model. Our graphical model is a graph, but specifically we're going to call it a visual representation. In some cases that will be a graph, right? But in other cases, if we were talking about something with statistics, we might have graphical being a pie chart, or we might have it being a histogram or something. So somehow it's a visual representation of what's going on. So those are our big models. And we know how to go from algebraic to graphical, right? We use Desmos to do that all the time. We don't necessarily know how to go the other way as well, but we'll get better at it. But those are probably the two where we are going to spend most of our time, is working with algebraic and graphical. We don't do a ton with verbal. It comes up off and on. We don't do a ton with numeric, mostly because we can get a better idea using these other two models, algebraic and graphical. So, but be mindful of how they fit together and how we can kind of work between different options.